I am Jim Diestel from Calient Networks, and what I want to talk about today is a specific application of how an optical switch can save money in a test and monitoring type environment, and I call it construction certification. And this is the process where the carriers introducing fiber to the home in a greenfield environment. Greenfield environments, as we all know, are not instantaneously turned on for service. It takes time to construct the site. The contractor or building company is putting in homes. They put them in at a certain rate. They usually use a multi-phased approach for the environment. The people then that buy homes and move in may be spread out over 6 months, 12 months, even a couple of years before the housing development is fully complete. And this has been particularly stretched out with the housing crisis that we've had in this country for the last year and a half or so, home construction having been largely curtailed. What the issue is for the service provider is that they have contracted to have the fiber laid before the streets are put in, before all the homes are constructed. And how do they determine what the quality of that fiber construction was? How do they certify it? And they can go in today and do an OTDR trace. They've got an unterminated distant end, so they frequently go to the far end and test groups of fibers back towards the central office. So a crew is doing this, and this is often something contracted to the contractor who's done the trenching and the initial fiber deployment. But unless you absolutely have a quality record, you don't know whether bend radius was exceeded, the tension pool was exceeded on pulling the fibers through. You don't know what you're going to encounter when you come to the service environment. What we're proposing is that instead of just having this end-to-end connectivity test, that you actually run an OTDR test and it not be manually oriented, as in this particular case where you dispatch somebody out there to run the test, but that you are actually moving into the cross-connect capability where you're putting the F1 and F2 fibers both through a splitter via dedicated test fiber. This allows you to alternatively do a cascaded deployment of your splitters, some of the splitters at the central office, some of the splitters at the CO. Maybe I can better explain it here. You can have the splitter network here and here. This is principally a European type model where they'll have a 2-to-1 or a 4-to-1 splitter in the central office and an 8-to-1 splitter that is passive in the central office or the outside plant. But you still need to then connect these different fiber segments and test them all. Or you can come in and you can start looking at an intelligent cross-connect capability where you would actually have a device that would go in and configure the terminations, run an OTDR test. This would all be done in a remote manner. It is one thing, as we've talked so far, to be running a test and have it take 30 seconds to 3 minutes for the OTDR trace time to actually occur. Having a technician with a handheld device or somebody at the central office doing this, it's an even greater step of inefficiency to have somebody at the central office not even there. This is a test that now is set up with a prearranged script to cycle through the fibers one at a time, and then all the OTDR test results are saved as baseline and loaded into the system for future troubleshooting purposes, and they can compare against a baseline threshold level that would show whether there was a problem with the construction. And all of this would occur literally before the contractor could even leave the site. So if it is a outside contractor, the service provider who is paying for this has a certainty of the quality before installation occurs. They know when they make the final payment on the construction effort that it is for good quality plant. It also gives them then this material for doing advanced troubleshooting. Now, taking a look at this cascaded splitter architecture, because this is the European model. Oops. We've got the splitters at the head end and at the fiber distribution hut or hub. And we can do the construction certification in this particular case with an intelligent cross-connect. And the intelligent cross-connect is not doing the physical testing. That is our partners down here at the end of the table who supply the test equipment, the OTDR, the software intelligence to test through these splitter networks. We are supplying the access to the physical fibers, that there is a device connecting all the fibers that will allow for the insertion of an OTDR test signal or burst and shoot the fiber and collect those data results. In this particular situation, we are on the subscriber side of the OLT. We have the ability to test the F1 segment of the fiber, which is defined here. And we can do either a half manual or fully automated effort at the FDH. At the FDH, if we have a situation where they have fibers or splitters that are at the ratio that cannot be tested through, we can test those F2 lines remotely by having a single OTDR in the central office with a fiber line and it be manually connected to each F2 one at a time, in which case we do have personnel involved, or we have a portable test set that would be, or optical switch that would be placed in there to run through the testing. Ultimately, rather than a portable one, we'd want a permanently installed one. But as we've discussed earlier, there are some significant challenges to an FDH deployment. We'll probably see optical switching in the CO and at MDUs before we get into the outside plant FDH. But the way it works is you just come online, test one fiber, and then you're just cycling through all the fibers one splitter at a time, and you just go through all that. Now, what I wanted to show is some actual information from carrier-based studies. And here is a situation that is actually based upon Telefonica. Telefonica trial that has been in place since September of last year in Spain. And we have a 2-to-1 split in the central office and an 8-to-1 split at the fiber distribution hub. Now, with an 8-to-1 split ratio, we are able to use a relatively standard OTDR to test through to see what's happening on the F2 lines. We were able to go in and actually put in an average cost of capital per connection, reduce the need for a fiber distribution frame at the central office, have $10 worth of equipment savings, and say $59 worth of test savings, and we have now a capital savings, and these would be capitalized test time because they're associated with the construction certification. And then there's annual operational savings that occurs after that. But on day one, a 40% rate of return on the deployment cost of the fiber distribution frame. So that answers some of your concerns about what is this actually going to cost. It is something that does start to return on the capital basis almost immediately. Now, if we were to go even one step further and put an optical switch at the FDH, We can then do any ratio of splitters, 1 to 32, 1 to 64, 1 to 8, whatever is necessary, and either switch around the splitters to test the F2 or test through them to test all the way through, depending on the testing capabilities. In this situation, we have an even greater opportunity. We're deploying twice the amount of switching capital, $200, than before, because we have a switch in both the central office and the FTTH. And then we are saving now the fiber distribution frame cost. At the central office, it's a little more expensive than in the outside plant. They're smaller units, more compact. So we don't save as much there, but or there isn't as much to save, because the capital cost of a FTTH cross-connect frame is relatively low. We have equipment savings, but the test savings are dramatic. $276 because we have no technician time involved at all. We have literally about 30 seconds of time at the Network Operations Center to turn on the test, and then the script runs, and about some, 4 hours, 5 hours later, test results are now available, downloaded, and locked in as baseline traces of OTDR, and a summarized report can be given. So you have a huge rate of return. Now, we've actually talked to one U.S. carrier who, based upon the number of homes that they are projecting to save, there's $325 million worth of operational savings associated with this. That is a huge, huge opportunity. And what we are finding is that this is indeed playing out in the real world. These are real carrier numbers. This is what it's really costing them to go out and do the test. Ray mentioned in some of his studies some of the complexities that they actually run into, and the multiple dispatches, that the 3 crews are dispatched for sectionalization, and when they finally get it sectionalized, 2 of them go home with nothing to do just because they had to meet a mean time to repair a bogey. In this particular situation, they are able to do all of that instantaneously if it's a repair environment. But this is purely justified on a capital basis. It goes beyond being capital neutral. It is actually capital positive. Now, adding another element to this, and this is something I think we're really just starting to see the very beginnings of, and it's much more expansive and aggressive in Europe, is environmental regulation. All of you as carriers are going to be increasingly held to a commitment to reduce your CO2 emissions. It is not just a situation where you can maintain what you have done the year before. You're going to actually have to dramatically reduce the expenditure on power, the exhaust of heat, and so on. Now, when you start thinking of some of the capabilities of an all-optic, automated, intelligent cross-connect and monitoring system, you are now saving this, changing this notion of immediate dispatch to satisfy mean time to repair criteria and quality criteria. You're changing it to I immediately test and diagnose, because I can do that from the NOC with the equipment that's in place. I can even reroute or reprovision around many problems. I have taken trucks off the street. There's actually some indication that I can take as much as 40% of the truck dispatches out of the equation. There are still going to be fiber cuts that have to require somebody to go out. There will be equipment failure at the ONU, ONTs, that will require dispatch, but 40% of the dispatches can be eliminated. Now, if you translate that to your vehicle fleet, you get a carbon footprint reduction. And that actually equates to something that is, so many tons of carbon emissions that can be traded on a cap and exchange trading database that is something that is coming. In Europe, it's at $21 a metric ton right now. So, manual fiber patch panel is the last unautomated component of a network. It's the last point where people have to go and be touching things, hands in the plant. We now have the ability to take that out of the equation, to automate it, add intelligence, do that from a construction standpoint as the foundation, and justification is based upon the savings in construction, and then get additional savings as you go forward with troubleshooting and day-to-day operations. Now's the time to take a look at it. Any questions? Yes, sir.
Put a end-to-end switch out in your FTTH and you lost power to that FTTH. Do things just stay as they are, or does the whole thing shut down?
If I put the question is, if I put a optical switch in the FTTH, if I lose power, does everything shut down or stay the same? A good portion of that depends on the solutions, the technologies of the individual optical switch. Sandy had mentioned that they have a naturally latching capability with their product, and in that particular case, you just have lost communications with the device or the ability to, go out there and affect new changes, but all your connections are satisfied. In our particular case, we require a continuous power source to maintain the connections, but what we supply is a battery supply, an 8-hour battery supply to latch equipment in place. And so there are alternative solutions for that, but you are indeed putting a powered active device in the outside plant when the desire is to remove as much of that as possible. But as we've seen with so many other pieces of equipment, it's just it's not possible for the carriers to remove all power from the outside plant.
So your cost justification for this is actually it actually offsets the cost of all that power, conditioning, backup power, and so on and so forth, and replacing the outside plant.
Yes, that is our position. Now, recognize that for a complete positive return on a capitalized basis, you've got to deploy the switches at both the FTTH and at the central office. And there are, valid concerns about that. There is, the fact that you're putting power in the outside plant, which some people have religious arguments against. There is a problem that there is insertion loss associated with these products. It varies by technology, but if you are putting it in, you do have to adjust your range for your PON system or your point-to-point systems, whatever. But those are all things that can be engineered.
And you're estimating with that particular calculation, it's going to be $13 per customer?
The actual cost will depend upon a number of factors: penetration rates that the carrier is achieving, versus homes passed. It also varies based upon the cost of the technology. When I'm talking about numbers, I'm talking about a fairly large deployment at some volume-based pricing.
Based on, say, like a Verizon or AT&T?
Clearly, a large carrier putting in this equipment across the network gets the best pricing. Unless everybody in this room wants to form a co-op, and then you could buy in the same quantities.
If you moved your splitters back into the central office, which is one of your design capabilities, have you guys done a financial analysis of what that does? Because then you can have both your switches in the central office. You're obviously spending more money on fiber and a little bit outside plant. What's that look like?
Okay. The question is, have we considered moving the splitters all back to the central office, and what does that do to the basic application and payback? It's an excellent question. It's been looked at a great deal. What we found is, with carrier input, that the additional fiber for the longer point-to-point runs from the CO all the way to the subscriber are basically a wash against much of the savings then that is accrued to that. So we think that that is a very valid solution. However, it is not a solution that major deployments like Verizon have considered. They have a very defined architecture. It is based upon a concentrated FTTH with up to 10 splitters in it, and that they are then serving from that, and they're fairly committed to that with 5 years worth of deployment behind them. In newer environments, you do have that point-to-point. NTT does a 4-to-1 split from the central office. Korea Telecom has a split. Everything is in the central office, so it's all point-to-point after that. And then, of course, there are many operators that are deploying straight point-to-point systems, not necessarily even PON, and it works as equally well in that environment.
I'm going to ask you sort of like a futuristic type question. This is one of the things that I've been bringing up as far as what I want to gear our training courses towards, is maintaining flexibility. Do you feel that this is going to be a more flexible type of a network, or the possibility of not necessarily just because of repair capability or it's being transferred and so on and so forth, but do you feel that it's a necessary form of flexibility within the network in order to be able to make future changes as well?
The question is, in the context of training courses and the future, do we see this as a capability that is really robust and will add flexibility to the network? Yes, we do. Probably the most relevant way that I've found to explain what we're doing is to compare to what happened with the digital revolution that occurred in the 70s, and you brought in the DAX capability. DAX supplied test access, technology migration capability as your cable plant, your transmission plant was digitized, and you were digitizing the central offices. How did you juggle the two of those happening at unequal periods of time? They put a digital cross-connect in between that then could facilitate a switch in, a switch out of technology for technology upgrade if there were issues with it. They could do half and half type deployments. They could maintain their existing infrastructure along with the new infrastructure. That is very much what we're doing with the optical cross connect. It is a DAX only for the fiber arena. And we are seeing more and more fiber going into the outside plant. We already have predominantly a fiber-based inter-office plant. How do we link up the changing equipment dynamics of bandwidth and protocols without endless cross-connecting and patch cords and damage with hands in the plant, inadvertent though it may be? It does happen. The best way to do it is from the ground zero, have that flexibility built in with a software-controlled optical cross-connect. So I think the flexibility is there. It's going to happen. It's just a question of when will it happen and exactly where will it happen. Clearly, the central office environment makes sense. Demarcation points make sense. Where most of us, where our companies have found success has been demarcation points, carrier hotels, internet exchanges, submarine cable landings. Those niche type applications, we've been fairly successful with deployments.
Just kind of add to his question. So I know a lot of these designs and the diagrams we've looked at fiber to the home because we just came from the Fiber Home Council Expo. But the switching is product neutral. It would pass DWC or DWDM, SONET, whatever else you put on it. I mean, it wouldn't care.
Yeah. The question is the product neutral from a fiber perspective of DWDM, CWDM, and so on? Yes, all the technologies are neutral. They are operating at the physical layer. They are switching the fibers themselves. So it can be a 40-channel DWDM system. It could be a single fiber. It could be after the transponders and individual wavelengths individual channels. It could be whatever you plug in is whatever is going to go out. There is no electrical conversion, so it's just a matter of moving the signal. So it is transparent. Anything else? Well, thank you very much.